So besides this being the happiest day of the week, like Mondays usually are, this also marks the start of our next unit, which is on systems of equations. So it's like you have an extra benefit for Monday. As far as system goes, think of system as just being more than one. So more than one what? More than one equation. Yeah. So the types of equations we're going to be working with are functions, more specifically linear functions. So what are we going to have? We're going to have more than one line. Systems of equations, just like regular equations, can be solved. And there's three different ways of solving them. Today, we'll explore the first one, which is graphing. Now, the reason why graphing gets taught first is because it's visual. And since so many of us are visual learners, we get to actually see the solution taking place. But the negative about graphing is that it's not very precise. So we kind of eventually drift away, and by eventually I mean by tomorrow, we will drift away from graphing and we'll find a more precise method for solving systems. But this is a nice introduction because you get to see the solution taking place. So if you heard me say that a system is more than one, if you heard me say that these equations are going to be linear functions, linear, line, and I get two lines and I graph them on the same plane, what do you think I would be looking for? Intersect, that's a better word. You don't want it?
Better give it back.
No, give it back. No, you gotta earn it. No, yeah. Okay, so if I take two lines and graph them on the same plane, they will interact with each other one of three different ways. That's not saying that every single graph is going to look exactly like these three, but in regards to the way that they relate to each other, what word almost gained Mohammed a candy? Intersection, sure. What can you tell me about the way these first graphs are intersecting? Yes, Hiram.
They cross over each other.
Yeah, that's what an intersection is. Yeah? No, well, I mean, they might be, but that's just a coincidence. I actually don't think they are, but it's close, yeah. Well, this is where you would actually like look at the paper. Yeah, that they're correct, that they're crossing once. And then you look at the second one and you're like, whoa, wait. I hate to be the bearer of bad news, but it looks like you forgot to put the second line there. To which I would reply, no, it's there. Ooh. The second line is there, but they're just on top of each other. So if one line is on top of the other, and a line by definition is made up of an infinite amount of points, at how many points will they be touching? An infinite amount, sure. And then on the last example here, you may know that these lines are parallel. You might know what the word parallel means. But what we care about more today is the fact how many times do parallel lines intersect? None. So I could say that when I put two lines on a graph, they will either intersect once, intersect always, or intersect never. And word association, the words I want you to associate are the words intersection with solution. So a system of linear equations can either have one solution, infinite solutions, or no solution. If you have one solution, and these will be the most common ones, if you have one solution, you should be able to tell me where that solution takes place. What are the coordinates of the intersection? What? You have an extra one? If we have infinite solutions, because we're choosing to graph first, you should be able to tell me that the reason why we have infinite solutions is because both lines that we're graphing, both equations, are the same. And then if we have no solution, it's because the lines are parallel. Okay. Now, when it comes to graphing, look, if we've already had a unit on just graphing, so one we just finished before, it's the most recent one. Okay, but there we were only graphing one equation at a time. And in that unit, we learned how to graph 3 different ways. We learned how to graph out of slope-intercept, point slope, and standard. But what we're going to do in this unit is we're going to exclusively graph out of slope-intercept. If a line is not in slope-intercept form, we're going to put it in slope-intercept form, because the nice thing about that is if you put the equations in slope-intercept form before we graph anything, you can tell me what type of solution you're going to have. Now, if they're going to cross once, you can't tell me where they cross until you graph it. But before you graph anything, by the fact that they're both in slope-intercept form, you can tell me what type. So does anybody want to take a wild guess how you could tell me before you graph anything when you have one intersection? Yes, Hiram? Hey, look at that. What a smart kid. He gets his lifesavers back. If we have infinite intersections or no intersections, yeah, we're actually going to have the same slope in both, obviously, because the different slope is being taken up by one intersection. Those other two, what they have in common is they have the same slope, but where we differentiate between the two of them is that two lines are going to be the same. They're going to have the same everything. So same slope and same y-intercept if we have infinite solutions. If we have no solution, same slope, different y-intercept. So now we get the party started with examples. The nice thing about this first example is that both equations are already in slope-intercept form. So, Jordan, what's the slope of the first one? Good. And what's the y-intercept? Good. What is the slope? Keep on going, Jordan. You can just finish. What is the slope of the second? 3 over 2. Good. And what's the y-intercept? So I am about to solve this, and I'm going to solve by graphing. But before I graph anything, can you tell me what type of solution we're going to have and why? Jordan, I'll give you the first shot. Since you gave me all the information, I'll give you the first shot. Can you tell me what type of solution and why? No? Daniel? Very good. Careful. Sorry. Yeah, we're going to have one intersection, which means one solution, and that's going to be because we have different slopes. The two slopes are different. So now, the reason why we're going to graph is so that we can see where that intersection is. First one starts at 0, 7. Slope is 1 over 2. Up 1, right 2, or down 1, left 2. Down 1, left 2. Connect the dots. Here's one equation. The other one is at 0, 3. The slope is 3 over 2. So up 3, right 2, down 3, left 2. If you knew how to graph one line, you should be fine. You have to know what direction positive slopes go, what direction negative slopes go. And Viola. You know, this is the kind of the also, it's the nice thing because you get to see the intersection, but it's also the bad part about it because it lacks precision. You know, you might be slightly off and it gets confusing, but where does it appear that these two lines are crossing at?
Let me see. If I'm not mistaken.
Mm-hmm. And that would be correct. It would be at 4. If you're ever not sure and you want to check, what this means is that in both of these equations, I should be able to plug in a 4 for x and get a 9 for y. Just for this first example, let's test that out. Jasmine, what's half of 4? 2 plus 7 is 9. Good. Jasmine, what is 4 times 3? Divided by 2? 6. Good. Plus 3? Thanks, Jasmine. Sometimes your friends call you Jasmine? Like Princess Jasmine? So this has one solution, and that solution would be at 4, 9. Okay. Let's do this one together. Well, if there's no solution, there would be no point.
No, I'm not saying the answer is one solution.
Depends on what the question's asking. If the question's only asking you how many solutions, then you would write that. But I'm just writing both. If they ask you for what is the solution and you only write the point, that's fine. Okay, so even though we learned to graph in different forms before, let's put these all into slope-intercept. Hiram, how would I get the first one into slope-intercept form? Yeah, divide 4, Ariana. First equation, how would I get it into slope-intercept?
Oh, you subtract 3.
Good, minus 3x on both sides. So y equals negative 3x plus 2. Oh, sorry. It's Santa candy. And then for the second one, Hiram? Now, yeah, I want to get this into slope-intercept form, so I'm going to put the x's first. Negative 12x divided by 4 is negative 3x. 12 divided by 4 is 3. So can somebody tell me the type of solution and why? Go ahead, Mohammed. Morgan, you want to give it a shot? So meaning what type of solution is that going to be? What? Well, that's what it's going to look like, but. And Mohammed will be assist. Okay, so the first one, now look, now this one, when you graph it though, it's going to be hard to see because these graphs are going to be super close. There's going to be like a little space between them. Is that you, Harry? You're supposed to be learning CPR and advising on Wednesday, so. If somebody had to give you CPR, Harold, who would you want it to be? Mohammed? Okay, so the other one is at 0, 3, and then also up 3, left 1, or down 3, right 1. This system has no intersection and therefore has no solution. If you want a shortcut for no solution, like that's the symbol for no solution. It's called the empty set. If they were to ask you for a reason why there's no solution in your graphing, you would say it's because the lines are parallel. Intercept, like in football, like an interception. Intersect. Okay, this next example. Slope is 2/1. Y-intercept is 0, -2. On the next one, you can just divide both sides by 2. We're trying to get them both in slope-intercept form. Y equals 2x. So then somebody not named Morgan or Hiram or Daniel or Mohammed. Somebody else, Charles, tell me what type of solution on Y? Y.
Whoa.
I was just trying to cheer him up because it's like a party in here. He's gonna start fist pumping now. Yeah. So even though there's two different lines, if both lines are the same, how many times did you graph them?
It's not funny.
It was never funny. There's nothing funny about that.
Oh yeah, I forgot this class is fun.
Nope. No fun allowed. So this has infinite solutions. And really because it's on the same line. Just when you write this is the important information. Everything else I'm writing is just supplementary.
That's it.
Yeah, that's the important part. Sorry, infinite solutions. You're 180 degrees.
Hey. I got a really funny stream. Not really, most of y'all.
That's not nice.
It's straight.
98 degrees is the name of Hiram's favorite boy band. Go ahead, do this one. Raise your hand when you got it. That's this one you do on your own. Let me know what type of solution, where the solution is. Rob, you got the answer already? No. You got it? What'd you get, Danielito?
Okay, so it's
What's the solution?
it's a one intersection, right? One intersection is two. Huh?
Yeah, 2 -4s don't work.
What?
Yeah, it's definitely not 2 negative 4. What'd you get?
I got y equals 3 times 2. What?
Mm-hmm. That makes even less sense. I want the actual solution to the system. I did been said that.
Wait, I got it.
No, I got it first. Oh, I got it. No. The solution is one intersection.
Hey, you're.
You did not even say the solution. Did he say
Wait,
the
actually,
solution?
hold on. No, give back.
Why? I was just right. Mr. Remember me up, please. That's right. That was right.
It's one selection.
One selection.
One selection? No. You're close, but no. He's very close. You might want to take a closer look there, Daniel. You're not that far away.
Oh, I got it. It's -5 and -1.
Mm.
No, you don't.
On my keys. Is y equal -1, -5?
No. Oh, is it -3, -3?
What? Just keep. Is y equal -1? It's -5. Because you got front row. So why we put that together?
-2.53.
He's throwing those lightsabers up in the air like if he just doesn't care. Nobody got it? Nobody wants to take one of the chairs? No. Daniel's gonna get really angry when he sees the answer, though. I'll tell you that. He's gonna come up with a new anger dance to show his frustration. So -6x minus 6x, -2y is equal to -6x, which is 12, divided by -2, y equals 3x minus 2. Slope is 3 over 1, y-intercept is 0, -2. Minus 3x minus 3x. 3y is equal to -3x minus 18 divided by 3. Y is equal to -x minus 6. So slope is -1 over 1. Y-intercept is 0, -6. Well, let's see what happens in your graph. I told you you're going to be angry.
I thought you wanted to tell you that.
Yeah, I'm about to do that. I'm not done yet. 0, -2.
I'm sorry, it's Daniel 1x. What?
You really do.
I really got this right.
The second one.
I equal -1x minus 6.
You got it right.
Yo, where's the mothers here?
I forgot to
we don't have to touch that much. It's not a big deal.
Why would you say that?
No, you said -5, -1, and I guess you were guessing based on what you said.
Yeah, you got it right. Yes, you got it right.
Man, I heard that. And I said negative. Oh yeah.
I did say you were close. I said you're gonna be angry. I said, Daniel, you're really close. I said, go back and look at it again. Daniel, you're really close. Daniel, you're really close. Hey, Daniel, you're gonna get really angry when you see what it actually is because you were so close. He forgot the sign. All right, how about this one?
So that looks like a negative sign. I mean, not a negative, it's a division sign. It's an addition. You gotta be more specific.
Somebody raise their hand. Give me the solution. Who wants to give me the solution?
Come on, Coach.
So you're gonna have to then rely on your extra super senses. Raise your hand. Yes, Mohammed. Parallel, that doesn't make any sense. Okay, so what are the two slopes?
3/4 is a slope.
Okay.
And then the other one is -4 is like the y, and then 0.75.
You're just saying way too many words.
-4.
What did we learn about no solution, about parallel lines? Let.
I think I got it.
And what else? And what else? Same slope, different y-intercept. So tell me what the same slope is. What slope do both of these lines have? 3/4. Good. And what are the two different y-intercepts?
Wait, so they don't intersect? So they don't intersect. Thank you, Mr. Brown.
You're welcome.
Oh my God.
Why are you mad, bro?
It's sour, mister.
They are quite sour.
Oh my God. Wrong?
Danny, with all that dancing you were doing earlier, you're not. I would think you'd be in a better mood. But I like him better though.
I mean, better. You don't like us. You don't like us.
Because it's parallel and they're across, so we can make the two lines they cross, so it's just like no solution. Like I'm over here talking, I'm moving on to the next round.
This system has Okay, how about this one? You would do anything for a Twizzler? What'd you get?
No solution has the same slope, which is negative 2.5, and then the y-intercept. Well, actually, it's one solution. Both, and they have the same thing, which is negative 2.5 plus 10.
Anybody else?
I got it wrong.
Wait, I'm still solving it.
I thought I got it right.
I know you ain't that, bro. That's like 20 seconds.
Oh, okay.
Yeah, Jordan? Well, I didn't use the word many.
I got the answer.
Or what did I use? Yes.
It's infinite solution.
Ah! Now what's the slope?
What?
Slope is?
Slope is negative 5 too.
You like be quiet. You got it wrong either way. It's 5 over 2x. It's negative 5. It's negative 5.
And the y-intercept? Y-intercept?
The y-intercept.
For a go, you never like. Man, Mr. Romero, where you get this in there? What store? Walmart, what?
Store right down the street.
Alright, the next one. Go, solve. Solve your little hearts out.
My heart is broken, Mr. Romero. Then give me a big pack of Skittles.
I'm done. Final answer is same slope. We did what did we do?
What is that same slope?
Negative 2x.
It's not your prime.
It's Hiram.
Negative 2x. And the different slopes, the different y-intercepts is plus 4 and negative 3. If I'm not mistaken. If I'm not wrong.
Wow.
He's a big guy here, right? He's a big guy. Come on, see you got a big book.
Okay, so let's see. First one, 4x plus 2y equals 8. The second one says y equals negative 2x minus 3. So what Hiram did before everybody else with his supersonic speed is he solved for the first y, and that gave him negative 2x plus 4. So both lines had a slope of negative 2 over 1, but the first one had a y-intercept of 4, and the second one had. slope of negative, y-intercept of negative 3. So 0, 4, down 2, right 1, down 2, right 1.
We should be quiet.
I am just going to retire from football to focus on that. Oh, yeah, speaking of which, thank you for bringing that up. If you noticed over the weekend, I posted everybody's midterm, which actually wasn't as good as you might think it was, but the county applies a curve to it, so the score you're seeing is an adjusted score. Just if you were to see, I don't know, like let's say maybe you saw a 76 and you're bragging to all your friends that you got a 76, that doesn't necessarily mean that you got 76% correct, but it means that the county adjusted it to a 76.
County saw true potential.
Yeah, exactly. The other thing is, you'll see it tomorrow, but I put in the assignment grades that were due last night. Okay, so you might think, oh, but hey, mister, like that was so much work, and remember you had 2 weeks to do it. Okay, if you are gonna complain that there was too much work, I would at least hope you did something, because I saw a lot of 0, 0, 0, 0. So you might say that it's not enough time to do it all, but I would say that, well, it's enough time to do something. A lot of people did nothing. And then the last thing would be, when it came time, I obviously didn't want to tell you this because you would take advantage of it. When it came time to grade it, and I averaged it, I didn't divide by 28. I divided by 20. So, well, you tell me, when you divide by smaller numbers, does the number get bigger or smaller?
Smaller.
Bigger. It gets bigger, yeah. So, so what ended up happening, unless you, see, if you did nothing, 0 divided by anything is still going to be 0. But as long as you did something, your grade was higher than it would have been, to the point where the people that did either all of it or close to all of it, there was some people that got above 100%. So whatever you get that goes above 100% ends up almost acting like extra credit. Yeah. What? You got the next one already? You have a sweet tooth?
Yeah.
Yeah. Go ahead, Charles. What'd you get? And what is that intersection? Huh? -3, -1? No, not this one.
I got -4, -2.
Okay, so on the one that Daniel just stole from you. 0, 0. A slope of 1 over 2 is up 1 and to the right 2. Then on the other one, crossing at 0, 2, up 1, right 1, down 1, left 1. Eventually, what did I do wrong? Oh no, I just did it before. There you go.
Just remember, I got the next one. I got the next one. How am I cheating? I beat him. How?
So this the solution here. Please make sure you're paying attention so you don't mess these up on the test. That test is not going to be a multiple choice. Does anybody that hasn't got anything yet want to try for the next one? Oh, you have enough already. Angel wants one?
Metabolism not gonna get big. It's fine. It's fine.
Let me give everybody else a chance. Rob likes participating. He's an excellent participator. Elizabeth, you got an answer? It's not like the seventh example, but it's one of the example 7.
Yes.
So this one people mess up because they forget that when there's no x, you don't do nothing. No, you do something. It's just the slope is 0, and it's going to be a horizontal line. So all I need is 1 point, and then I draw a horizontal line across that point. Did you have that on your paper, Danielito? I believe you. Daniel, we trust. So then 3y is equal to negative 2x plus 3 divided by 3. Y is equal to negative 2/3 x plus 1. Start at plus 1. Negatives go up, left, down, right. So if you keep on going, you're eventually going to cross out. Eventually cross at 6, negative 3. If those wrappers end up on the floor, that'll be the last time anybody here gets candy. Okay, the last one. I'll give you guys a chance. What's up, man? To the varsity math team? Good. What'd you get, Daniel?
Come on, dang, man. I know what it is, though. Hold up, I know what it is. Hold up, I know what it is. Hey!
He has a high metabolism.
That's what I want.
I think all that extra sugar is making him crazy.
I don't know.
Okay, so the first one was just plus 6x. Then the reason why Daniel gets all the girls is because he knew the slope was 641. And the y-intercept was 0.4. Are you picking on Muhammad?
Yeah.
Don't bully him. Plus 2x, plus 2x. Most of the girls on the cheerleading team pick on Muhammad. It's not fun. Okay, so 0, 4, 6, 1, down 6, left 1. -4, 0, -4, and then up to left one. I already found it. I ended up crossing paths. Any other questions for me?
No, sir.
Okay.